NAT exemption is the exemption of IP addresses from the NAT process of the NAT device, meaning the NAT policy won't be applied to a specific set of IP addresses. There are many reasons as to why you might want to exempt IP addresses from the NAT process, but the most common ones are that of legacy policy-based IPsec VPNs and remote access VPNs. Let's take a look at policy-based VPNs as an example. Now, these VPNs are triggered based on interesting traffic, which is defined by IP addresses in an access control list. NAT would certainly pose a problem for them because of the order of operations of NAT in Cisco routers, according to which NAT occurs before the crypto map check. So that means VPN traffic will be heading towards the ISP instead of the IPsec tunnel. So to mitigate this, we need to apply NAT exemption where necessary depending upon your network connectivity. So in this lab, we will deep dive into NAT exemption and see how it works. Let's jump in. Now, NAT exemption becomes really important when you have IPsec tunnels towards banks, towards your branches, or whatnot. And I'm talking about the legacy IPsec tunnels. I'm not talking about GRA. I'm not talking about the VDI tunnels. I'm specifically talking about the IPsec tunnel that you all may have heard about. I mean, that is the tunnel that has been around for eons. And we have that same tunnel between our HQ site and our branch site. So it's time to give you a quick lab overview. All right, on the left side, we have an HQ site which has two PCs, which are not actually PCs, they are routers, because I don't actually use the VPCs that we have in Eve NG community, because sometimes I've seen they get a little buggy, so I opt in using routers and I change the icons to a PC. So that is why you see these PCs over here. And then we have a switch. We have this switch, every port of it is in VLAN 1 and all of its ports are in access port. And then we have our NAT router, or we could call this an HQ router in this case. And then we have the internet, or our ISP. Now, again, this internet that you see over here is basically a router that I've changed the icon and to represent as a cloud. And then on the above, we have a Google server. It doesn't have any services running on it. We are just going to be testing it with simple ICMP pings, pings to 4.2.2.2 from PC A and B and also C. So it is directly connected to this internet router. Now, this Google server is also just a router, and I've just changed the icon to a server. You can possibly do that really easy, really quick. It's really simple. Okay, on the right side, we have a branch site. So basically why I did this, because I needed another site or a bank or something that I can connect to via IPsec tunnel. As you can see in the middle, we have an IPsec tunnel established between them. I mean, we have it configured. We haven't really tested it. We're going to be testing this as well. But I really want to emphasize on this, that we are not actually going to go really in depth into IPsec tunnels. We'll see some basic commands and stuff and some show commands because it's already configured and we haven't tested it. But our major focus will be on NAT exemption and why do we need it when we're using NAT overload with an IPsec tunnel between our sites or any place else. Okay, without wasting any more time, let's begin our lab. First of all, lab information. Everything except the NAT configuration on the NAT router and branch router has been configured. So the NAT router is this router over here on our HQ site, and the branch router is over here on our branch site. All right, that's okay. So the IP addresses like the 200.1.1.1 and 192.168.10.254 that you see here have already been configured, and routing has also been configured, which is only a default route pointing towards the ISP of HQ site, and similar is the case with the branch router. All the end devices are router in disguise of a host. So basically what I meant is that these guys that you see over here, this guy, and this guy, they are basically routers. So if I were to see the CLI of these devices, these are basically routers, which I've named PCA and whatnot. So I basically do that because they're a little buggy. So if you've been following me, you know well why I do that. So I don't actually like the virtual PCs, but you can use them. They're really light. I have a good amount of RAM actually to facilitate in these devices as routers, so I do that. Okay, let's head on to our first step of this lab, and that is verify IPsec VPN connectivity between sites before initiating the NAT statements. Now that is true and reasonable because I have to test it out first, because once I have the NAT configured, I'm going to be testing NAT with IPsec. What actually happens when you have NAT configured and IPsec with it. So let's jump into my router, NAT router 1. I mean, just one. I mean, there is only one NAT router. So let me just show you this. Show run section crypto. I have phase 1 of IKE already configured and phase 2 as well. So I will include these commands in the materials section as well as for your reference. So we only have this policy configured, and we're using pre-shared, and this is a pre-shared key, and that is the address of the remote router. And this is basically IPsec phase, which is overlapping with our other phase. Let me show you like this, section IPsec. So, okay, that is the IPsec transform set that we have. We're using AES as encryption and hash as HMAC. And we have this crypto map configured that has peer set to 100.1.1.1, which is our other site, this one. And we have the transform set call over here, and the group 1 and match address DN VPN traffic. This is basically an access list. Or here, let me just show you. This is the access list that we have configured up till now. This is for the interesting traffic, as you may well know if you have ever dealt with policy-based VPNs. This VPN basically is characterized as a policy-based VPN. You also have route-based VPNs, or whenever you configure those tunnel interfaces, which are IPsec native or with GRE or IPsec. So those are basically called route-based VPNs. So we have our policy-based VPN configured. Let's just do a show IPsec, show crypto, IPsec SA. Nothing too much over there. So show crypto ISACAP. First of all, let's verify the phase 1 SA. So there is nothing actually over here. Now the thing is that I need to generate some traffic. Now, as you have seen in the access list just before this, the interesting traffic is whenever traffic is originating from 192.168.10.0/24 subnet and going towards 10.1.1.0/24, which is actually this subnet over here running on the branch side. So to generate traffic, what I could do sitting on this router is I could do a ping 10.1.1. I'll just ping this guy 10.1.1.254 and 254, and I'm gonna set the source to whatever my source is, and that is gig 0/0, which is configured for 192.168.10.254. I could just type in the IP address, or I could say gig 0/0. So any IP address that is configured on gig 0/0 will be used for that traffic. Okay. So as you can see, the source was 192.168.10.254, and the pings were successful. Now let's do a show crypto IPsec SA, and we can see packets have been encrypted and being decrypted, and the number is the same. So everything is working fine with respect to the IPsec. So that verifies our first step. All right, let's head over to step 2, and that is configure NAT inside and outside interfaces on the NAT router and the branch router. I could have just named it HQ router, but okay, so sorry about the naming convention. So let's say gig 0/0, first of all, on the NAT router. That's going to be host name. Oh, sorry, host name. That's going to be interface gig 0/0. That's going to be IP NAT inside, which our inside hosts reside on. And then we have gig 0/0, this side of the router. That's going to be IP NAT outside. So it'll take some time over here. So let's configure the other one. All right, so it's gig 0/1 is on the inside, so let's do that real quick. Interface gig 0/1 IP NAT inside, and it's going to take some time as well. So we can do the remaining NAT configuration on this NAT router, and that is on gig 0/1. So I'll be saying, okay, going on to the NAT router, it's back online. Do show IP interface brief, exclude unsigned. So as you can see, we have this interface facing towards the ISP, so it's IP NAT outside. And so we have both the NAT interfaces configured. We can show IP NAT statistics, maybe. Yeah, sorry, not maybe, but this is the command actually to see which of your interfaces are configured on that. So you could do a show run interface gig 0/1 and also do a gig 0/0 if you want it, and you can see which interfaces are configured. And we have one remaining, and that is the interface of gig 0/0, I believe. Let's do show IP NAT statistics. And okay, we only have 0/1 configured, and that is for inside interface. And let's do interface gig 0/0 IP NAT outside. All right, so that was pretty easy. We've done this, and let's move on to the next step. All right, in the third step, we need to configure NAT overload on both the routers, NAT router, which is the HQ router, that router, and the branch router. Both of them need to be configured for NAT overload. So let's do that real quick. So let's hit global configuration mode, and if you've seen the NAT overload video from the beginner series, it's the first lab of that series. Then we need to configure an IP access list defining this subnet that we have over here, and do that real quick. IP access extended, and I told you in that lab that extended is the key whenever you come across Nat Exemption. Very useful. So we're going to say internet is the name of that ACL, and say permit IP 192.168.10.0.0.0 wildcard mask, and going towards any. And let's do a deny IP any as well, which is already present over here. The implicit deny is present, but for brevity's sake, I'm just doing that. Okay, the access list is configured. Now let's configure the NAT statement. So as IP NAT inside source list, you specify the list you just created, internet, and interface. So you can define the interface. So what's the interface of the outgoing? There it is. That is gig 0/1. That is the one facing the outside and has a public IP address. So gig 0/1. Right. Oh, sorry, I forgot the overload keyword. Maybe it just added it itself. I believe it can. Let me just show you that really quick. If it added it, yeah, there it is. So there was nothing else it could actually do, because I wasn't referring a pool or anything, so it had to do an overload. Again, the latest releases in the iOSs do that for you if you mistakenly don't type the thing. So let's go towards the branch router. Now, the branch router has 10.1.1.0/24 subnet, so let's configure that real quick. IP access extended, internet, permit IP 10.1.1.0.0.0.255 any, and deny IP any. So there it is, IP NAT inside source list, and internet. I hope I'm not going too fast. internet interface. Let's see what the interface is. The out-facing interface towards the internet is gig0/0. So gig0/0 overload. So there it is. So we basically have the NAT configured at this point. Now we need to do test connectivity with 4.2.2.2. So heading towards PCA, first of all, on the HQ side over here, I'm going to try to ping the Google server from here. So bring up PCA, show IP interface brief. First of all, let me show you. There it is. I only have IP address configured and a default route that a normal PC does have. So let's do a ping. First of all, our gateway, or not. No, let's just do it front. 10.254. Let's see if you can ping it. There it is. You can ping it. And let's try to ping 4.2.2.2. There it is. Beautiful. Now, if you were to look at the NAT router, show IP NAT translations. So you can see that this was the inside local address, and this was the global address. It was ICMP, a ping packet going towards 4.2.2.2. And this we have discussed in lecture number 2, I believe, or it was, I don't know actually which lecture it was in the previous series. So a port number is automatically assigned to the session to make any kind of translation possible. Now let's head over to branch router and see if branch PC, that is PCC, and see if it can actually go and ping 4.2.2. Beautiful, it can too. So show IP NAT translations, and there it is. So, whoa, I didn't know it could assign a 0 port number. Oh, that's a new one. So there it is. You've got both the PCs. Let me just go to topology. Both the PCs from here, from PCA, you can ping the Google server, and from PCC, you can also ping the Google server. So that wraps up our step number 3. Now coming to our 4th step, that is define the need for NAT exemption and configure it accordingly on both sides. Now before jumping into the testing part, let me just bring up the NAT order of operations, which in lecture number 4 in the beginner series I discussed, but I did not discuss any other parameters apart from the routing. So if you see here, if the packet is coming from an inside interface and going towards an outside interface, which could be the case if PCA is heading towards 4.2.2.2 in this case, what's going to happen is, ignore all these up till this, routing is performed. So NAT router has the default route pointing towards the ISP, so routing is present over there. And then we have the NAT statement, whatever it is, it triggers that. Now the problem with legacy IPsec policy-based VPNs is this. As you can see, NAT occurs, and then we have the crypto. Now what is the crypto? If you don't remember that, let me just show you. If you head over to the NAT router, we basically went ahead and saw the IPsec parameters and everything, but we forgot to see where does that crypto map actually apply to. So the outgoing interface is gig0/1, right? So interface gig0/1, let's do a show run on that, and you can see the crypto map is applied on this interface. So what will happen is that NAT is occurring first, and then crypto map is checked. So if PCA wants to communicate with PCC on the right side, on the branch site, then it cannot do that. Now here's why. Remember that IPsec tunnel is working. We just tested that, didn't we? So what happens if PCA generates an ICMP packet destined for 10.1.1.1, which is PCC's address? The NAT router on the HQ site gets the packet and sees how can it reach the destination 10.1.1.1. Now we don't have a GRE tunnel or a VTI tunnel, we have a policy-based IPsec tunnel. So for that, the outgoing interface needs to be pointing towards your ISP, or any way that you could reach the branch router which is on 100.1.1.1. Now that is all fine until the routing part. If I show you the NAT order of operations, routing is being performed and it's all good. The problem is over here. NAT translation will happen before triggering the IPsec tunnel, because the source IP address of PCA will be changed to 200.1.1.1, and that crypto map that we just saw, let me just show you that. And that was not the crypto map, but the access list called in that crypto map won't be hit. As you can see, the source IP address needs to be 192.168.10.0. But in our case, if NAT occurs first, the IP address is going to be changed to 200.1.1.1, and the policy-based VPN won't trigger. So what's going to happen, that destination which it was trying to reach, which in this case was 10.1.1.1, is going to be directly forwarded to the ISP, and it's going to drop it because it's a private IP address of RFC 1918, and those aren't allowed on the ISP sides. They have filters to block that. Now to show you that real quick, let's head on to PCA and do a ping to 10.1.1.1, and you see unreachables are coming out. Now that is because this router or this ISP is getting the packet directly. It's not being encrypted in the IPsec tunnel. So that is where NAT exemption will kick in. Now NAT exemption will say, I don't want to NAT these guys. I mean, if the traffic is coming from 192.168.1.10 subnet and going towards 10.1.1.0/24 subnet, I don't want that to be NATed, and that is called NAT exemption. So let me show you how it's done. It's pretty simple. It's just one command actually. I mean, the concept is the key actually. So we have this internet ACL, and let's go IP access list extended internet. And if I just do a deny over here, what's going to happen is that the sequence number is going to be 30, and we don't want that after the deny any. So we have to do it before the 10th sequence. So let's do it sequence number 5, and we're going to do a deny. Now anything that is denied when it comes to NAT is not being NATed, okay? Whenever you're calling this ACL in a NAT statement, so that basically means don't NAT these guys. So what I'm going to be doing is saying, okay, deny IP, all right, what it is, 192.168.10.0.0.0.255, going towards 10.1.1.0, and that is the wildcard mask, and that's it. Now the same thing needs to be done on the other side as well. Here we are, because they need to be exempted too, because the return traffic will be a problem over here. Let me just check that real quick. You see, the return traffic will be the problem if we don't configure NAT exemption on the other side. Now the unreachables are gone because the ISP is not sending that. I cannot reach that subnet because I don't have any information of that. So let's go to the branch side and do the same. Do show IP access list. We have the same access list name configured there. IP access list extended internet. Oh, sorry, just misspelled it. That's why you should always copy paste in production environments. This could be an issue, and I have dealt with this issue many times. So, but I'm still gonna write it down. It's not that hard actually, but ACLs in the production are really hard to, write down. So this one was a very easy one. So, okay, I'm just going to do 5 sequence because it is a more specific sequence, so it must be above 10. So deny IP. Now this time it's going to be the other way around, just like this DN VPN traffic. Actually, it's going to be the same one. Let me just copy and paste that. There you go. It's kind of like the same one. Now do show IP access list. I didn't do that before. Let's try to ping it now. Fingers crossed. Boom, that's working. So let's check this out. Show IP access. Oh, sorry. First of all, the show IP NAT translations. So there are no translations. So PCA, when communicating with PCC, is not being netted. So that's great. Now, sorry again. Let's check. What do we need to check? Let's check our show crypto IPsec essay. Now, there are 14 and 9 packets. Let's see. Oh man, let's do it again with a repeat count of 100. Oh God. Sorry about that. So let's go to and do a show IP. You see that they're being changed. I mean, really much incremented. So that means the VPN tunnel is being used and they have not been natted. So that is basically NAT exemption. Very simple concept to implement, but the concept is the key. So you've understood why you need NAT exemption when it comes to things like the IPsec tunnel. And I'm talking about the legacy IPsec tunnel. Whenever you have interfaces like GRE or VTI, those are tunnel interfaces and they have an interface number. Now, whenever you have an interface number, IPNAT outside or inside command must be configured on them for NAT to trigger. So that won't be the case for them, but it will be the case for this scenario. And just to show you that they can access Google and they are being natted. So let's do a 4 out of ping and 4 out of 2. And sure enough, show IP NAT translations are happening. Well, I hope this has been informative for you, and I'd like to thank you for viewing.